Hey guys, this is Mrs. Hardman and welcome to Algebra 2. This is the presentation for 2.7, distances and midpoints. We are still talking about equations and graphs, and today we're going to look at finding the distance and midpoint between 2 points on a graph. Our biblical correlation for our unit is this, from Hebrews 3:12-14. See to it, brothers, that none of you has a sinful, unbelieving heart that turns away from the living God, but encourage one another daily. We've come to share in the Christ if we hold firmly to the end of the confidence we had at first. We have been talking all throughout this unit about relationships. We see relationships in math and relationships in nature and relationships in science, and we see relationships in humanity. And we need to make sure that we are encouraging one another and encouraging positive and godly relationships. Our lesson objective for today is this. You, the student, will find distances and midpoints by applying the appropriate formulas. Now, this is something that you have hopefully done before on the number line, finding distances and midpoints. We do it all the time when we're driving. You leave exit 310, you're going to get off at exit 317. You know the distance between 310 and 317 is 7 miles. Or let's say you're trying to meet somebody who lives far away and you want to find the halfway point. And you know there's 500 miles between the two of you. You know that halfway point or that midpoint is 250 miles for both of you. And you would find that location on a map and agree to meet there. So we use distances and midpoint all the time, especially in navigation and in driving. On a number line, the distance between points with coordinates A and B is the absolute value of their differences. So exit 317 minus exit 310, that's a difference of 7. The absolute value is 7. The distance is 7. A midpoint is the average of these coordinates. So again, if we're getting on the interstate at exit 0 and we have to drive 500 miles, then that midpoint, or the average of those two, 500 plus 0 divided by 2, is 250. That's our midpoint. So that's how we do that on a number line. It's not too different when we move on to a Cartesian plane. Here's our official distance formula or definition. The distance, d, between any 2 points, point 1 is x and y, and point 2 is x2, y2, is given by this formula. x2 minus x1 squared plus y2 minus y1 squared, and then take the square root of that. Okay. That is a formula that you are going to need to know how to use and remember. So let's see what that means. Hopefully, this will make you think of that Pythagorean theorem where a squared plus b squared equals c squared. And we can go back and we can relate this distance formula to our Pythagorean theorem. Here's point 1, here's point 2, and we know that this squared plus this squared equals this squared. So we're relating that back to the Pythagorean theorem. If you're a little unsure about the Pythagorean theorem, we can plug some numbers here in class and see how that works out. Let's practice using this formula and find the distance between these 2 points, -4, 2, 1, and 7. So the first thing we're going to do is write the distance formula. Then we'll substitute our values in and evaluate. Remember to use parentheses when you substitute to keep those signs intact and honor your signs. We've got parentheses here. We need them also here and here and here. So let's add this parentheses to make sure we are using our signs correctly. That simplifies down to the square root of 50. The square root of 50 we can also write as 5 times the square root of 2. If we're trying to get an exact measure to the nearest decimal, we would write that as 7.07. 7.07. I'm not sure if you remember how to simplify your radicals. So if you're looking at this and you don't know how we got to that, please make a note on your notes and remember to ask me next class and we'll go over simplifying radicals. The midpoint, or M, of the segment connecting P1 and P2 is given by this formula. The average of x1 plus x2, so x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Again, let's use these segments and plug it into the formula. First, we're going to write our midpoint formula. Then we'll substitute in our values. Again, use parentheses anytime that you're subbing. It will just help you in the long run if you get into the habit of using those parentheses. we end up with -1 and 13/2 as a midpoint coordinates. Now, just as we can designate a point in a plane, using the Cartesian plane, for example, using an ordered pair, we can designate a point in space by an ordered triple. So the Cartesian plane is flat. It's two-dimensional, it's an x, and it's a y. But we can also designate points using ordered pairs, using x, y, and z in 3D. So this would be helpful when we're trying to describe points in a particular area that has height and depth and width. All right, so this is a little confusing if you don't have good spatial reasoning, but this line right here, hopefully you can see that. That is our x coordinate, and here is our y coordinate. So it's like our Cartesian plane is laying flat, and this space, straight up and down, is our z coordinate. So our x coordinate is 1. So you can see we moved over 1 on our x coordinate. I'm going to write these numbers sideways here. 1, 2, 3, 4, and 5. Okay, our y coordinate is 2. So here's our y coordinates. 1, 2, 3. So you may be doing what I'm doing right now and turning your head sideways to kind of try to imagine that x and y. And then our z coordinate is that height, how high we're going. And our z coordinate is 3. So 1, 2, 3. So this might be useful if we're trying to, again, find a specific coordinate or specific location in a three-dimensional space. When we're talking about distance and midpoint involving three-dimensional shapes, this should look very similar, but now instead of x2, x1, y2, and y1, we've added z2 and z1 to our distance formula. And our midpoint formula will also look similar. We have the midpoint of x, the midpoint of y, and then our midpoint of our z coordinate. Let's find the length of the segment with endpoints 2, -1, and 3, and 3, 5, and -1. We'll write our original equation, substitute those in. Again, use parentheses when you substitute. It's a good habit to get into, even though there are not all parentheses here. When we simplify that, we end up with a square root of 53. And in decimal form, if we want an exact distance, we can translate that to 7.28 to the nearest hundredth. What about the midpoint? Try this one on your own and see if you can find the midpoint. Pause the video and come back when you think you've got it. All right, we're going to start with our midpoint formula here. Plug in our different numbers, and we find our midpoint is 5/2, 2, and 1. So today we looked at the following things. We found distances of both 2D and 3D objects and midpoints of 2D and 3D objects by applying the appropriate distance and midpoint formulas. If you guys have any questions about how to simplify radicals, the Pythagorean theorem, or how exactly that 3D graph looks, make sure you ask me next class.